To understand the universe on a bigger scale and a minute particle like quark on a very small scale, we need to understand force. Force is push or pull. Force can do for us a lot. We exert force on the ground due to our weight. When we stretch rubber, we apply force on it. The engine of a car exerts force to move the car. A bird flying in air is thrusting itself in the forward direction with the force. What forces can do for us? Force can start or tends to start motion in a body. For example, by applying force on a chair, it moves. Force can stop or tend to stop a moving body. For example, a goalkeeper tries to stop the football in order to prevent the goal. Force can speed up the slow moving body or change direction. For example, a football player pushes the ball towards another player to speed it up or to change its direction. A force can change the length or shape. For example, pressing the spring or stretching the spring decreases or increases the size of the spring, and squeezing a lemon changes the size of the lemon. Quantifying force. In System International, the unit of force is Newton. How much is 1 Newton? The gravitational force exerted on 100-gram apple by Earth is equal to 1 Newton. It's a very small value. To measure force, we use spring balance, or it is also known as Newton meter. It was Robert Hooke who investigated the extension caused in spring when it is stretched, and the work of Hooke led to the development of spring balance. Some estimated force values are: force needed to switch on the light is 10 Newton. Force produced by tug of war team is 5,000 Newton. Force exerted by a jet engine is 1,50,000 Newton. Different forces are: gravitational force, that is the force which is exerted by one body on another or one mass on another. For example, Earth is exerting force on the moon. Sun is exerting force on all the planets in its planetary system. These forces are called gravitational forces. Magnetic force. The force between the magnets is known as magnetic force. We know that the south and north poles, they attract each other, while the north and north, they repel each other, and this force is known as magnetic force. Electric force is between charges, or it is known as electrostatic force. We know that positive charges repel each other, and positive and negative charges attract each other. The next is weight. Weight is the pull of Earth on objects. It is always in the downward direction. Normal reaction is the force opposite to the weight when a book is lying on the table. The upward force is the normal force, which is exerted by the table on the book, while the weight is downward. Impact force. When a moving body hits another body, it exerts force on the other body, and their force is known as impact force. For example, when a truck collides with a wall or with another vehicle, it exerts force on another wall or vehicle, and their force is known as impact force. Friction force. Force which opposes motion of bodies is known as friction force. For example, the tire has threads on it and the road is rough. So the roughness of the tire and the road is causing a force which opposes the motion of a body is called friction force. Strain force or restoring force. When force is applied on a spring to stretch it, the spring also exerts force in the opposite direction to restore its shape and size, and that force is known as strain force or restoring force. Tension force is a stretching force in a spring, string, or rope. For example, in a figure, there is a body hanging with a string. The weight of the body is in the downward direction, while the upward force is known as a tension force. Centripetal force, force which compels the body to move in circular path, is called centripetal force or center-seeking force. For example, moon orbits around the earth, and the force exerted by earth on moon is centripetal force. It always keeps the moon in the circular orbit. And the formula of this force is F is equal to mv squared divided by r, where m is the mass of the moon V is the velocity of the moon, and r is the radius of rotation. Balanced forces. Two forces equal in magnitude and opposite in direction are said to be balanced. When balanced forces act on a body, the body is either at rest or moving with uniform velocity, and this led Newton to formulate a law called Newton's first law of motion, and according to which, in the absence of a net external force, a body at rest will remain at rest, and the body in motion will continue its uniform motion in a straight line. For example, a book lying on a table. There are two forces acting on it. One is the weight of the book, which is in the downward direction, and the other is normal force, which is in the upward direction. Both the forces are equal in magnitude and opposite in direction, and that is why the book is at rest. Similarly, consider an aircraft moving in air with uniform velocity. There are four forces acting on it. One is weight of the aircraft, which is in the downward direction. The other is the lift from the wings, which is in the upward direction. The other is the friction or the air resistance, that is in the backward direction. And the other is the engine thrust, that is in the forward direction. Scalar quantities. Those physical quantities which can be completely described by a number and a proper unit are called scalars. For example, distance, speed, volume, work, energy, and power. These quantities are also called non-directional quantities. That is, to represent distance, for example, there is no need to mention direction. Similarly, for speed, we only say the magnitude and the unit. For example, we say a car is moving with the 20 meters per second. So 20 is a number which shows how fast or slow the body is, and meter per second is the unit of the speed. Opposite to scalar, there are vectors. Those physical quantities for which we need direction as well, they are called vectors. That is, besides magnitude, we need direction as well. For example, we have displacement, velocity, acceleration, force, weight, and torque. For instance, we represent displacement. So displacement is the menu of directed distance. That is, to represent displacement, we need direction as well. Similar is the case with velocity. Their speed in a particular direction becomes velocity. So those physical quantities which can be completely described by a number, proper unit, as well as direction, they are said to be vector quantities, or you can say directional quantities. How vectors are represented? Vectors are represented by an arrow. The length of the arrow is equal to the magnitude of the physical quantity, and the direction of the arrow represents the direction of the physical quantity. Now, for example, there's a car which is moving with a velocity of 20 meters per second towards east, and you want to draw a representative line for this physical quantity, which is velocity. So what we do, first we choose a scale according to our own choice. For example, we say that 4 meters per second is 1 centimeter. Now this 1 centimeter will represent 4 meters per second. Using geographical direction, we draw the representative line, which will be 5 centimeters towards east, and then we draw geographical direction for us, and then we draw the vector with its magnitude and direction according to the scale chosen. So our vector is 5 centimeters towards east. That is the representative line of 20 meters per second. Now consider another example. A force of 60 Newton acting on a body with an angle of 30 degrees along x-axis. First step, make a scale. For instance, we take 10 Newton as 1 centimeter. Then 60 Newton will be equal to 6 centimeter. Now we draw 6 centimeter along x-axis, which makes an angle of 30 degrees with x-axis. So first we take x-axis, then we put protractor and we mark 30 degrees. Along that we draw the vector, which is 6 centimeter, and the angle is represented as 30 degrees. Vectors addition. The sum of two or more vectors is equal to a single vector and is called a resultant vector. This single vector must represent the combining effect of all the vectors in the process of addition in terms of magnitude and direction. For example, now addition of parallel and antiparallel vectors. Consider a box on which three forces are acting. As all the forces are acting in the same direction, so we add them up. One force is 2 Newton, the second is third, and the third is 4th Newton. And when we add them up, we get 9 Newton. So on the box, the resultant force is 9 Newton towards the right. If there are two forces acting in opposite direction, both are equal in magnitude and opposite in direction, so the resultant will be 0. And in this way, the resultant force is 0 Newton. Now, if there is one force which is 8 Newton towards east and the other is 5 Newtons towards west, applying on the same body, then what we do, we subtract smaller force from the larger, and as a result we get 8 minus 5, which is 3 Newton towards the larger force, that is 3 Newton towards east. In this way, this body will move towards east with a force of 3 Newton. Till here, this was the part 1 of the chapter, and in part 2 of the video, we will discuss head-to-tail rule, parallelograms, law vectors, addition, and solution of past paper questions.